Thank you for coming tonight, everybody. My name is Cassie Soping. I work with the Globe Mission Mosquito Program. And tonight I'm joined by five amazing projects tonight to share with you. And the scientists that are collecting and using the data that you're submitting are here to explain their project and what you can do with the data. So I'll start with, on top left-hand corner of my screen is Marile.
Hello, everybody. My name is Marile Robles, and I'm excited to be here with you. I am the project scientist for the cloud observations in the GLOBE program. So every time that you make a cloud observation, it comes to the team here at NASA Langley Research Center, where we compare your observations to satellite data, send it back to you in a NASA personalized email, and then we also look at your data and see and use it for different research purposes. So thank you so much for being here tonight.
And next on my screen is Emily and Tori.
Hi, everyone. I'm Emily Sousa, and I work at the University of Alaska Fairbanks International Arctic Research Center, and I'm part of the Globe Alaska team. And we put together a phenology video for today. So very excited to be here and sharing this webinar with everyone else too. And Tori, I'll pass it off to you.
I'm Tori Brannon. I'm lucky enough to work with Emily at the International Arctic Research Center for the University of Alaska Fairbanks. I'm a science education specialist and program manager, and Emily's support team for this venture.
And Kevin.
Hi, I'm Kevin Czajkowski. I'm a professor at the University of Toledo in the Department of Geography and Planning, and I'm also the PI for Globe Mission Earth. It's a NASA-funded project. And I lead up the Urban Heat Island Intensive Observation Period for Globe.
And Christy.
Hi, everybody. Thanks so much for coming. I am also with the Globe Alaska team. I work at the Geophysical Institute at the Geographic Information Network of Alaska. And I love seeing everybody's data that you enter into Globe. And I just met a scientist today and introduced that scientist to Globe for the first time. And they're so excited about accessing all of your data that you collect. I am the principal investigator of a NASA SNOWX and Globe reciprocal mentoring and collaboration grant that I'll be talking about more. I'll be having a student present with me on Monday. So good to have everybody here. Thanks so much.
Thank you. Ashley.
Hi, I'm Ashley. I actually work with both Globe and MineAcid data. So with Globe, I work with Marile, and I actually use the Globe Observer data for research projects. I'm representing Angie, whose video you will see later, representing MineAcid data and how you can use us and our tools to help explore more data.
Thank you very much. And Alison, I saved you for last to wrap introductions up.
Hi, everybody. It's an honor to be here with all of our panelists. My name is Alison Mote, and I am an education specialist with the Globe Implementation Office. And one of the big projects I'm in charge of is the International Virtual Science Symposium. So I'll provide you with a little bit of an overview of that tonight.
Thank you. I welcome you to the first of two webinars to discover resources to support your Globe students' research during the 2024-25 school year, and hopefully to prepare them to enter their research into the 2025 Globe International Virtual Science Symposium. These webinars will feature subject matter experts sharing their research, the type of Globe data it generates, and examples of research questions your kids can explore using this data. You may have heard science activation or SciAct and wonder what that means. These projects are part of a cooperative network of competitively selected teams from across the nation working with NASA infrastructure activities to share NASA science with learners of all ages. Yes, we are recording, and you'll be able to pick that link up later. And information on the IVSS can be found at this link. And there is an IVSS 2025 playlist with lots of helpful things that Alison will talk about in a moment. So this is a Zoom webinar, and the best way to get your question answered would be either the chat or the Q&A, and I've circled the two. So please feel free to use either one that works for you. And there should be a reaction option also. Feel free to use that during someone's presentation or during a question and answer period. Tonight, we're going to hear from our subject matter experts and scientists on Globe's Urban Heat Island Effect Campaign, Globe Trees Around the Globe Student Research Campaign, Globe Clouds, Globe Phenology with specific Alaskan examples, and wrapping it up with my NASA data. So again, if you have any questions during anybody's presentation, please be sure to use the Q&A, and all of us are online ready to answer your questions. With that, I'm going to turn it over to Alison.
Excellent. Thank you, Cassie. If you want to go to the next slide, I'm going to provide just a real high-level overview of the IVSS for those of you who aren't familiar. And I'll also speak to some of the specific thematic elements for this year's IVSS. And feel free to pop any questions in the chat. I'm happy to answer them as we go. But first of all, I just wanted to kind of address what the IVSS is and the benefit to students. So the International Virtual Science Symposium is an online symposium for students to share their GLOBE research with STEM professionals in the GLOBE community. And it's a great opportunity for students to get valuable feedback on their work. We have judges from all over the world who provide feedback on student projects. And the IVSS is open to GLOBE students in K through 16. And we've got rubrics by grade level for student projects. Next slide, please. And one of the really excellent elements of the IVSS is that it provides students with an opportunity to not only do their own research, but they really get to engage in scientific problem-solving skills. So as part of the IVSS, students can earn badges to showcase the scientific and engineering practices that they engage with as they complete their research project. So I've got the I am a student researcher really prominently shown in the middle of the screen here. All students who submit an IVSS project and whose projects are judged earn a student researcher badge. And then in addition to that, students can write about other skills or work that they've engaged with, such as working with STEM professionals, to kind of showcase the work of their projects. So students can earn these digital badges, which is a way to just showcase their skills that they've gained throughout their work. Next slide. And so the IVSS project requirements are shown on the screen, and I'll share the IVSS website in just a moment. But in order for projects to be included in the judging process, students need to include an abstract or summary. They need to include a written research report, an explanation for each badge. So as I mentioned, all students earn the student researcher badge, but then they can choose up to 3 additional badges that they would like to earn as part of their project. And then they also include a presentation with their work, which I'll speak about in just a minute. And then the last thing is, if any images of students or adults are included in the project, they have to include photo releases along with their project. Next slide. So examples of presentations, and we've got resources for all of these things on the IVSS webpage, but really the goal of the presentations is for students to communicate their science. So you can see a picture here on the screen of students presenting a printed poster that they presented. So the options for presentations are a digital poster, like a science style poster. They can also record a presentation, so a narrated presentation that they record and submit a video link to, or they can create an ArcGIS story map to showcase the work that they've done. So really the goal is for students to be creative and communicate their science. And we've got guidelines for both the written report and the presentations on the IVSS student research or student resources page of our website. Next slide. And another benefit of the IVSS is that students have the opportunity to earn stipends as part of their work. So the Globe Implementation Office does a drawing on Earth Day every year for qualifying projects. And students, in order to qualify for the drawing, for the stipend drawing, students must earn 4 stars on their research project. So 4 stars is the maximum rubric score for a project. This year, they must also earn the featured badge for this year's theme. So the featured badge is the I'm a Data Scientist badge, and they must receive at least 2 additional badges along with that. For students who are selected for the stipend, so we draw 1 project from each globe region and 2 projects from the North American region. And student teams can use the stipend funds to offset the cost of attending the Globe annual meeting student experience. So I've got some pictures here of this past summer's student experience, which is a really amazing opportunity for students to attend and interact with other Globe community members, scientists, STEM professionals. They present their work in a poster session to the Globe community. And then they also engage in a 4-day-long research field experience with their Globe peers from around the world. So it's a really amazing experience for our students. And this year, the student experience will be held at the annual meeting, which is in July every summer in the US. And so this year, in order to be entered into the stipend drawing, students must earn the Data Scientist badge. So for this, we're asking that students, in celebration of Globe's 30th anniversary, so the 30th anniversary of Globe is on Earth Day 2025. So we're really encouraging students to access data from the Globe database. So for this, we're asking them to download and analyze data, as well as newly collected data if they are collecting their own data. So there are more guidelines for all of the badges, but in more detail, the Data Scientist badge is listed on our badges page on the IVSS website. Next slide. And so that kind of brings us to the theme of this webinar, and I'm really excited to hear from all of the panelists today. They're going to talk about ways to incorporate data from various NASA projects, but some suggestions for using past Globe data from the Globe database. There are a variety of options. So really the sky's the limit. We're just really asking students to get into the database and look at, we've got over 250 million data points there. So students might use the data to develop an understanding of Earth system processes, so part of their background research perhaps. They might use Globe data to help brainstorm research questions and develop hypotheses, or to help provide evidence for the explanations in their project. And really, we encourage students to look at data from any time period or region. So it doesn't necessarily have to be local data. If there's not local Globe data available, they can look at any part of the world or compare something locally to another part of the world. And we also encourage them to compare Globe data collected in the past to any newly collected data. So newly collected data is not a requirement of IVSS projects, but we definitely encourage that as students engage with Globe protocols. And so I'll pop the link in the chat here for the IVSS, but there's a QR code there. You'll see that there are a lot of links on the left side, and we will be adding to the student resources, particularly related to the data component. So I encourage you to check out the IVSS webpage for more info, and I'll also put an email in the chat here. If you have any questions at all, please feel free to email, and I look forward to answering those emails. But thank you very much. I'm excited to hear from the panelists, and thank you, Cassie, for organizing this.
Thank you, Alison.
Oh, no worries. That was just my thank you slide with some images of our students and educators at this past year's Globe annual meeting student experience. So thank you.
Our first presenter is Kevin with the Globe Urban Heat Island Effects Campaign.
Hello, everyone. I'm Kevin Czajkowski. I'm a professor at the University of Toledo, and I'm the PI for Globe Mission Earth. That's a NASA Science Activation funded project. And I'm going to talk about urban heat island effect and how to get data from Globe to study the urban heat island effect. We've been doing a campaign in Globe and also an intensive observation period for many years. We've been trying to see, well, how is my neighborhood? How hot is it? I have collaborators at the University of Toledo who worked with me on this. I just wanted to show them there. Okay. So think about your urban heat islands. Every day you may experience warm places and cool places. Now, for myself, I live in a rural area. So when I get in my car, the temperature is a certain amount. But then when I drive to Toledo, it always is warmer in Toledo every day. It's amazing to me. So, some places with trees are cooler. A beach might be hot, although you could have a lake breeze or ocean breeze. And cities tend to be warmer than rural areas. And so that's what the urban heat island effect is. And this schematic shows that. Urban areas have more pavement, more buildings, less vegetation. Rural areas have more vegetation. Vegetation, water, they evapotranspire water. So that helps to cool the area. We measure surface temperature as part of the urban heat island campaign and intensive observation period because surface temperature is at the heart of the energy budget. You can see here how the sun is the source of energy for the Earth. The sunlight that makes it through the atmosphere warms the surface. That energy can go into evapotranspiration, as I mentioned, from plants transpiring water, and then also evaporation from the surface. Some of that energy can go into sensible heat, which that's the temperature we feel, and then some is emitted to space. And that energy that's emitted to space could be absorbed by greenhouse gases. So surface temperature kind of tells us a lot about the environment. The urban heat island intensive observation period is going on through October, December, and March. Those are the months we're doing it in for Globe. And we take 3 types of observations: cloud observations, air temperature, and surface temperature. You see the instruments over on the right. Surface temperature is taken with infrared thermometers. You can use a regular thermometer for air temperature and then your app for the cloud observations. So one of the things we wanted to find out this year was, how hot is your school? Is the parking lot making your school hot, or the playground, or maybe the artificial turf of a sports field? So those are the type of things we're looking at. In particular, for parking lots at high schools, students have been painting their parking spots. You can see that in the middle here. And we're wondering, well, does that change the temperature of the parking lot? Well, we hope to see. Now, we made a urban heat island effect page for students, and here's the link. It's a Google site, and it has a lot of information. It has videos of how to take surface temperature observations, and I think that could be helpful. And just to give an idea how many observations there were taken, in the year 2022-2023, you can see all the observations that were taken in the United States, South America, Europe, the Middle East, and Southeast Asia. But also air temperature. Now, the larger dots are weather stations. So Globe has a number of weather stations, but then people take observations with their instruments themselves. And you can see that as smaller observations, smaller dots. We do also have a satellite app through Google Earth Engine. So here's the link here. And you can use it to look at Landsat images of the surface temperature for anywhere in the world. Make sure you do a couple things. So make sure you pick like last year. If you pick imagery or dates too recent, the data is not uploaded to Google Earth Engine. Also, Landsat goes over each area about once every 16 days. So you want to pick at least 1 month for a time period so you make sure you get an image. So thank you, and I'm going to show how to plot some of your data and get some data off the Globe website. The Globe website has a great amount of data on the Urban Heat Island campaign and intensive observation period. So you go to globe.gov, click on Globe Data, and let's start by visualizing the data. to see what might be a good place to observe. Then you have to go down to enter the globe visualization system. That'll come up. Click on the pizza boxes. The instructions are here in case you forget. Click on the pizza boxes. Surface temperature is under atmosphere. We're going to scroll down to surface temperature. Click on the average and hit submit. Now, there's only been a few observations in the last day here, but we can do data counts and look over the last 5 years. So basically, we want to see who has a lot of observations, and then to see if we can compare an urban versus a rural area. You could do it over 30 years, but that's a lot of data, and that might take a long time to show up. You can see there's a lot in Ohio and Michigan, some across the United States. Croatia has a lot of observations. Parts of Europe, Nigeria, Saudi Arabia, the Middle East, and then parts of Thailand and Taiwan, for instance. And that'll pop up in a second. It just takes a second to refresh. There you go. So I want to look at Toledo. That's where I am. Let's zoom in. I'm also going to cut down the dates for to the last year. So I'm going to change that. Click on that. Change it to 2023. Click on October 1st, and it shows the dates for the year. Now, there's a bunch of rural observations here. There's a bunch of city observations here. I know these are mainly the University of Toledo, so I can check that. I don't know which these are, so let me click on those. Buckeye Central Local School District. So I'm going to try to get those observations. So I'm going to go back to the Globe website. You open it up again. We're going to use the ADAT system now. Go to Globe Data, Retrieve Data. You got to scroll down again, enter the Data Access tool. Now we're going to select the protocol, surface temperature. All right, let's see here. Add to filter. Date range, always good to have. Again, we got to change it back to that 2023. Let's do that. Let's do October 1st. I think that's what that is. Yep. Can even choose it. Play filter. And then we can click a site name. Let's try that. Oh, maybe it's school. Hang on a second. I'm going to change it to school. Click on school teacher partner. I'm going to type in Buckeye. There you go, Buckeye Central Local School District. Click on that. Add to filter. Apply filter. You see they have 21 sites. I want to obtain the measurement data. Click on that. And then download the data. Takes a second. All right, then I'm going to download that. That's going to go in my download file. All right, let me get the University of Toledo too. So I'm going to compare the University of Toledo with the Buckeye Central Local School District. University of Toledo is an urban area. The Buckeye Central Local School is nearby in a rural area. So I'm going to close that, X out of the Buckeye, add the school, and type in University. Yeah, a second. I have to move this bar. Of Toledo. Let's see what comes up for that. Okay, yeah, University of Toledo. So add that filter. Apply filter. 102 sites. Obtain measurement data is over 300 observations. That's going to take a little longer to download. You can see it counting down. 5, 4, 3, 2, 1. Okay, I'm going to download. Okay, now we're going to use CODAP. CODAP is a way of plotting data, and it can pick and upload the globe data pretty easily. So we're going to launch CODAP. All right, I'm going to create a new document. I'm going to click on the little arrow there, import, and it says drop a file here. So I'm going to go to my file downloads. Okay, the most recent download is right here. Let's see the first one here. Now I have to unzip it. So I have to double click, zip it, extract files. This is that ends in 8.2, so I have to keep track of that. So it's at the bottom of the list. So I'm going to drag and drop this into the list. All right, there's my data. It came into CodeApp really quick. The cool part is I can open the map. So I'm going to just click on the map. And it shows me where those observations are. You can see them here. You can zoom out. You can see how it is in relation to Toledo. And then we're going to do a graph. Before I do that, let me look over. I'm going to change the data type to, okay, edit attribute properties. I have to change it to numeric, type numeric, and apply. It comes in as text, not numeric. So we have to change it to numeric. I'm going to open a graph. And then I'm going to drag the data for surface temperature into the y-axis. You can see the distribution of values, -10 to 70. Now 70 could be a real observation, but that kind of seems like Fahrenheit, but we're not going to clean the data now. You may want to clean the data. And I want to see an average, so I'm going to click on this ruler. The ruler gives you some statistics. You could do like a box plot, look at the spread, and here's just the mean. So the mean, let's see, is 13.9. Okay, now I'm going to do the University of Toledo. So I'm going to open up, import a new data set. Let's see if that works. You have to go back here. I have to extract it again. Extract files. This ends in 8.3. Okay. Shows up at the bottom again. Is that right? I guess so. Open it. Drag it. And I'm going to create a new data set. Okay. All right, and that says University of Toledo. So that's a good sign. I'm going to expand that a little bit. Again, I have to change the data type to numeric. So I have to click on that, edit attribute properties, type numeric, apply. Let's map it just to see what happens. Map. Ooh, okay. So there's actually people took observations at other places in the United States other than Toledo. So that might cause some problems, but we'll see what happens. I know this was from the solar eclipse in April, and we had people at libraries across the United States taking observations. So we'll just ignore for now because, well, this is a quick study, and I'm doing it in under 8 minutes. So let's click on graph. Again, drag it a little bit, open it bigger. Again, I'm going to drag the surface temperature into the y-axis. There's the distribution. Oh, we got one in over 60. Could be. Got a lot down here under 0, which is fine too. Click on the mean. The mean is 18.1. So remember, the mean for Buckeye was 13.9. The mean for University of Toledo is 18. Now, there are other observations from maybe further south, so there's other things to look into. But anyway, this was one example of how you can do a comparison study pretty quickly using CodeApp. Thank you all, and good luck on your projects.
Thank you, Kevin. I was just going to type in the chat how cool this was, but it really is cool. If there's any questions at all, Kevin's here to answer them. And if you come on a question as we go, please type it in the chat regardless. So anything for Kevin? Kevin, is there anything you'd like to add to your?
Well, I might have posted in the chat to the host and panelists, but I could say this to everybody. I have my undergraduate and graduate students take observations as homework for my classes. So that's why there's so many in the city of Toledo. And they take their observations around their apartments and things like that, or their homes. So I get a nice distribution of temperature. I'm able to have infrared thermometers for all the students, and we've been using meat thermometers, and they're about $8 each for the air temperature. So I think the infrared thermometers I've gotten for about 15. So you might be able to get a grant. I know YLACES give, if you apply to grants from them, you might be able to get one through Globe, and buy them for a class set, have students take them at their homes to see what their neighborhood is like and compare different, their houses and stuff like that.
Well, thank you very much, Kevin.
You're welcome.
Next up is Brian Campbell with the Trees Around the Globe Student Research Campaign. And stepping in for Brian as the SME is Peter Nelson. So we'll start with Brian. And the volume's okay for everyone?
Hello, Globe IVSS 2025 student researchers and educators. I'm Brian Campbell, the Trees Around the Globe Student Research Campaign lead and the Globe Observer Tree Science lead. I'm coming to you from the NASA Wallops Flight Facility in Wallops Island, Virginia, in the United States. Behind me is a stand of trees that I measured using the Globe Observer Trees tool. Also, the NASA ICET-2 satellite measured the height of these trees as well from space. Today, I'm going to talk to you about how you can access the data from over 115,000 tree height observations from over 34,000 locations across the planet. Also, I want to show you how you can look to see what trees the ICET-2 satellite has measured. Let's go. Hey again, everyone, it's Brian. So let's go and take a look at where we can find the tree height data on the Globe page. So I'm at the landing page for the Globe program, www.globe.gov, and you'll see there these links across here, and one says Globe data. So I'm going to go ahead and click on that. And there are several ways you can do this. To take a look at what all the Globe data means to the user, you can look up the Globe data user guide. But to grab the tree height data, you can visualize the data, retrieve the data, and for those programmers out there who are really looking for the specific Globe data, there's the API. Today I'm going to show you the visualization system and the ADAT system. So let's click on Visualize Data. So when you do, you will go to the page that says Visualize Data, and you will enter the Globe visualization system. If you click on the link, and then you will get this familiar map that many of you know of. Do is go to these three dots, click on that, and choose my base map, because I like looking at the satellite image, not just the bare image. So then we will then go to the first icon with these layers on it, and I will go into Biosphere and click on tree heights, and there's two options, tree height and tree photos. Let's go ahead and do both of those. So I hit submit, and you can set it up for 1 day all the way through all, which will take you back to that just about 30 years of data. I'm going to keep it on 1 year, and what I'm going to do is click that update just to make sure that it's at 1 year. And you can see it takes a little bit for the tree photos to render, and they will pop up on here. There you go. But I want to get a little more specific. I'm looking at information in the state of Maryland in the United States where I live. So I'm going to go to this second icon. It kind of looks like a funnel. So I'm going to click on that, and I'm going to go down to Find Multiple Sites. And then I'm going to click on By Place, and I'm going to put in here Maryland. And you can put anything you like in here, country, city, state, and things most likely will pop up. I'm just going to put the state of Maryland. You can see it pops up here. So that's great. So when I hit submit, you can see these are measurements that have come in the state of Maryland over the last year. So down here is where I live in a town called Salisbury, Maryland. So I'm just going to zoom in a little bit and you'll see that the images continue to render a little bit. So I'm going to then just show you, if you click on a photo, okay, you will get this box that pops up with tabs that say measurement, data count, school info, site info, and photos. If you go to measurements, that's where it shows you the data for the tree height. And then there is some comments here. This happens to be one that I was investigating and observing on the campus of Salisbury University, nearby where I live. And this tree height happened to be 10.62 meters. So then at this spot, gives you data count, where I was, the site info with the latitude and longitude, and then a photo of the tree. Now, let me back out of that. Let's say you want to look at all of the state of Maryland. Well, we can then go back into here, and when we go into this first icon again, where it says tree height, if you click on these three dots here, you can view the layer table or download it. I'm going to hit view so you can see it on the screen. And what you get are the locations and school names in Maryland, the site name that Globe has given it, the latitude and longitude, the elevation, when it was measured, and the measured tree height value. And then you can also download this entire chart, okay? So that's a quick tutorial for the Globe visualization system. Now, I'm going to exit out of that and show you another way to do this when looking for tree heights. Back to the Globe program page, we're going to click on Globe data again, and we're going to hit retrieve data. That'll take us to the advanced data access tool with Globe. I'm going to enter that tool, and then I'm going to go over here to the left where it says select a filter, select protocols. I'm going to scroll down to tree heights, add that to filter, and you can put whatever date range you want. I'm just going to randomly choose one. I'm going to go here. It looks like August 19th of 2022 through October 10th of 2024. I'm going to hit add to filter. Okay. And then what I'm going to do here is I'm going to go under site filter. I'm going to put Maryland again. So I'm going to hit Maryland. I'm going to hit add to filter. I'm going to hit apply filter. Okay. So that looks like in that time frame, just over 2 years, there were measurements for 496 sites in Maryland. So that's great. So then I can click on obtain measurement data, and that allows you to download the data. So what I'm going to do here is I got to wait a second for it to download, and then it's going to ask you if you want to download it and see the data. So with that in mind, I'm going to wait here for a second. It might take a little bit to process. There we go. So I'm going to click on download, and then I'm going to save it to my desktop. So now you can see you will get a zip drive folder. So if you double click that, it will open up the spreadsheet. If you open that, it'll open in Excel. And let me widen this here. So you see there's lots of information on here, a lot more than what you saw on the layer table with the visualization system. But it'll tell you a lot more. A lot of the things that you saw before. It'll give you the elevation, when it was measured. But what I want to draw your attention to is this column R. This column R with all these numbers, these are where the tree heights come from. So you can search for an area in your location, and when you download this from ADAT, this spreadsheet, I want you to pay attention to column R. Those are the tree heights that are associated with the observations you are looking for. You can look at NASA data for tree height. If we go to Open Altimetry, you can see the URL up above. And once you get there, you click on ISAT2 data, and you will get this big map that pops up. Now, you can search by date. And what you're seeing here is all these lines are ISAT2 orbit paths, okay? These are just the orbit paths of ISAT2. But you can focus on particular regions, okay? So I'm going to click on this arrow underneath the magnifying glass because I can put in a latitude and longitude. So I'm going to put in a latitude and longitude in Maryland near where I live in Salisbury, Maryland. So my longitude, and please note the longitude is first on this. So I'm putting in my longitude for this. And I'm going to put my latitude of where I want to look for the data to see if ISET2 has any tree height observations here. And once I have those in, I'm going to update the map. And what will happen is it will center that location in the middle of the screen. So if I zoom in a bit, you will see these red lines. These red lines are past ISET2 orbits. So I can go ahead and click on these. And when I click on an orbit path, these dates will come up. So I'm not going to go deep into this, but what you can do is you can see if ISET2 measured any of the trees that you measured and then do some comparisons. So for instance, I'm going to just click on one of the dates, and it takes a second, but sometimes it takes a little bit for the photons to load up. Okay, there you go. So see, all of these dots here that you see are photons. So I'm going to zoom in just to show you something. I'm going to zoom in where it covered some trees so you can see what I'm looking for. So once you zoom in here, you can hit the select a region at the top left. And when you do that, you'll get this crosshatch. And then you hold your mouse down and you can put it around the photons you want to see what the height of these trees are. So if you let it go, it will say view elevation profile, view signal photons, or close. We're going to view elevation profile, and another window will pop up, and it'll take a second for the photons to load up. But what it'll give you two graphs. One is of the ground elevation and canopy surface, which are then aligned to individual tree height measurements. And when I say individual, each one of these photons has a footprint on the ground that's 13 meters in diameter. So all the trees that the photon landed on in that 13-meter diameter footprint, what we are getting back from ISET2 is the average of all those trees. So if you scroll over this, you can see that we have canopy heights of 11.78 meters, 16.64 meters. Over here, it's really tall one at 35.24 meters. So explore this, and I hope all of this helped you out a little bit, and you can please reach out to me if needed. My email is brian.a.campbell@nasa.gov. Thanks so much, and good luck on your research reports for IVSS 2025.
If there's any questions, you can be sure to ask Peter right now or put them into the chat. Peter, is there anything you'd like to add to Brian's video discussion? Briefly.
No, not at this point, Cassie. Brian did a great job of taking you through how to think about the canopy heights, and you can see how this ties together perfectly with what Kevin is measuring with the surface temperature. Right, we're measuring the trees and the ground, so very complementary efforts here.
Thank you. Up next is Marile with clouds.
Hello, my name is Marile Colon Robles, and I'm the project scientist for NASA Globe Cloud at NASA Langley Research Center in Hampton, Virginia, USA. The Globe Cloud team is extremely excited that you are considering making sky and cloud observations for your IVSS project. With clouds, it's important to recognize and observe the types of clouds that you're seeing, but also other types of observations like clear skies, dust storms, and smoke plumes from nearby fires, like wildfires. There are many ways that you can make observations yourself and also time them when there's a satellite overhead. The Globe Clouds team at NASA Langley Research Center compares your observations whenever possible to satellite data. So satellite data is moving right above, looking down, and your observations of clouds are from the ground looking up. And that comparison makes it a richer or a data set with multiple ways of looking at what's happening in the atmosphere. When you make an observation, you then get a NASA personalized email with a link to a table that compares your satellite observations to what you observed. This table, we have a website that walks you through the table, including all the different sections and what you see. Some of the projects you can do can be just looking at which satellites do you observe in your location. And how does it compare? Looking at total cloud cover or clouds by altitude. You can also click on these images and then you'll get the photo taken by the instrument on board the satellite centered on your location. Those are a few things that you can do. And remember that satellites give us information about the total cloud cover, the altitude of the clouds, the opacity, and the phase, which means what's inside of the cloud. Is it made by ice crystals, water droplets, or a mixture? That is very important to compare to your observations where you can tell us the opacity, the cloud cover, and the cloud types. Your photographs are always unique and important. It allows researchers like me to be right there next to you looking at your sky scene. It's very neat. Now, how can you get to your data? There's different ways that you can get to this data. If you have a Globe account or you have a teacher account, you can go, you sign in, and you go to My Observation. When you click on My Observation, you'll see the latest observations. You can type the type of observation that you made. You can click through the photos, see the details, and then you can get to your satellite match table right there by clicking on the link. If you go into the visualization system, you can go into the protocol layer, go into atmosphere, go into clouds, and I love looking at cloud photos. And these are all the cloud photos submitted today. You can look at different cloud types, interesting photographs or colors. And if you go back a little bit, you may be able to click on an observation and get to the satellite link right there. So notice if you go under measurement, it says satellite matching. You can open it in a new link, and then you can get that satellite comparison for that observation. Another thing I like to do is to see where observations are at, because maybe you're making an observation in a location that doesn't have an observation yet, and that is adding to the Globe database, which is very exciting. Now, in the Globe Clouds page on the Globe website, there is the Student Project Support webpage, where we have ideas for you on ways that you can make cloud observations, your cloud observations into a research project, including the cloud observations, contour identifications, so straight line clouds that are formed when an airplane passes by. You can even see if there's a relationship between the mood of your friends or your family members and the clouds and the cloud types of the cloud cover and other projects. We also have resources in Spanish. Para aquellos que hablan español, hay muchos recursos en español, incluyendo nuestra página. Y en la página de Observer también hay muchos videos y actividades en español. We also have our top 5 English and Spanish resources about clouds if you want to do that comparison. Also available in Spanish is the project poster where you fill in the blanks and it helps you walk through and develop your IVSS project in your presentation. So on behalf of the Globe Clouds team at NASA Langley Research Center, we are very excited that you will be studying or considering studying our atmosphere. We are here to help in any way, so you can contact us with any questions or any suggestions as ideas, or if you notice something in your data and you want to tell us in addition to your research, we would love to hear from you. Thank you so much.
Thank you very much, Marile. And if there's any questions for Marile, she's available.
I put all the resources in the chat and also my email if you want to reach out to me. I do see a question about ISAT2, the link to the telemetry page. So if somebody in the panelists can put that link there, Jason would really appreciate that.
Thank you. Next is using globe phenology data for your IVSS project. And Emily is online and able to answer any questions you have during her presentation.
Hi, I'm Emily Sousa, and I am a geospatial educator with Globe Alaska and the International Arctic Research Center at the University of Alaska Fairbanks. And I'm here today to talk about globe phenology data and using globe phenology data for your International Virtual Science Symposium project. So for those of you that were at the North American annual meeting this year, Globe annual meeting, you may have heard Dr. Katie Spellman say this little bit, but I want you to keep it in mind as you think about developing your phenology research questions. So globe observations tell the story of our past and can help us create the story of our future. So when you're thinking about developing your phenology research question, the two things I think are worth thinking about are what matters to my community. So when you're working with students, what matters to them, but also what matters to the folks in your community. And then what data do I have to work with? So to answer those questions, what matters to my community? You may want to talk to elders or local or indigenous knowledge holders or people who pay very close attention or have been around a long time, who might remember that year that it just seemed like it would never stop raining, or the year when the frost came early, or the year it was so hot. So they might be able to tell you those stories about those years, and then you might be able to find that in your phenology data. You might also want to talk to somebody who uses the resource. So in Alaska, we monitor birch a lot. And so we might want to talk to birch basket weavers or birch bark artists, people who gather firewood. We might want to talk to moose hunters because moose hunting season and green down coincide in Fairbanks, and how many leaves are on the trees can impact how easy it is to see where you're going when you're walking through the brush or see a moose. So think about who knows the land really well and who green down matters for. Maybe it's farmers, who else it is, but think about those folks and then talk to those folks. And then the second piece is what data do I have to work with? And that's where the globe phenology piece and that long-term record come in. So the theme this year being 30 years of globe data, there is a treasure trove of phenology data out there for you to look at. In Alaska, we've been collecting phenology data since 1999. In your community, it might not be that long. You might have a different time frame, but you can find places where phenology data has been taken at different times throughout the years, and you can use that in your research project. So I want to show you an example of a student-led research project using Globe Green Down data. So this is a group of 5th graders from Pearl Creek Elementary School, and they've been tracking Globe Green Down at their school for 4 years in a number of different classes. And what they wanted to know was, is there a relationship between the timing of green down and how warm or cold it is in the fall? And they thought the colder it was, the earlier green down would happen. So they went to the Globe website, they downloaded all of Pearl Creek's phenology data for the last 4 years, and then they actually converted their colors into percentages. So what they looked at was percent of leaves that are green percent of leaves that are changed, so yellow, brown, doesn't matter what color, just that they're no longer green, and then the percent of leaves that had fallen. And then they compared that with weather data. And so you can do this if you have a globe weather station, or you can talk to the weather service or a partner at the university to get that weather data. And you can do the same sort of thing with your data. So they looked at weather data, they looked at their warmer and cooler years, and they were surprised by the results because it wasn't what they thought. And that led them to ask different questions, including one, which we now have an undergraduate student at the University of Alaska Fairbanks investigating, which is the potential impact of little birch leaf miners, which are a little insect that the 5th grade students and the other students at Pearl Creek had noticed in the layers of the leaves that had turned the leaves brown. And so now we have a UAF student who's looking to see, can we tell by looking at the colors of the leaves in our 30-year record of data, can we tell the leaves that the birch leaf or the years that the birch leaf miner is having an impact? So really cool project that led to another really cool project. And you might have something similar that you can do in your community. So I want to show you what you get if you go to the Globe data visualization system. So Globe makes a bunch of ready-made charts for you. And so if you go to the Globe system, you find a site and you click on the site, what you're going to see is these charts of predominant leaf color by week. And that's really cool because just with that, without having to make your own charts or do your own data analysis, you can start to see some of the differences. So you can compare species. So half the class here took birch, half the class monitored poplar, and you can see the difference in the leaves. It also gives you the option to select leaf 1, 2, 3, or 4. So maybe you want to know something about how the position of the leaf on the tree impacts the color that it changes to. You can ask those questions with these ready-made figures on the Globe data visualization system. And there are data tutorials for how to use that on the website. So go to Globe and it can walk you through how to get this. So you can ask questions about different species, different leaves. You can also ask about different years. So this is the same site, 2024 versus 2023. And if you have multiple years of data at a site, you can ask those kinds of questions. If you go to the Globe Data Visualization Center, this is what you see right now. And this is all the sites that have collected green down data in the last year. So as you can see, there's a ton of good information out there, lots of sites collecting it in different places, different species, so lots to work with. If you want to go a little bit further and you want to do a little bit of data analysis or manipulate the data, you can download the data spreadsheet. And so to do that, you go to the Advanced Data Access tool. And again, on the website, there is a tutorial for how to do this. So take your time with it and work through it. But what you're going to want to do is filter down to what you want and then download measurement data. And then it's going to pop up this giant spreadsheet, which is just full of data. What's nice is the second row gives you explanations of what each column is. So if it looks a little overwhelming, don't worry, there are explanations. And then from there, you can do things like the Pearl Creek students did, where we added up all of the leaves every week that were green and the ones that were changed and the ones that were on the tree or fallen and converted them to percentages. And so you can do that too, or you can do other things. The nice thing about this is once you've downloaded that spreadsheet, you can do whatever you want to it. It won't impact the data on the Globe website. That website holds the data, keeps it safe so that you can do your data analysis or whatever you want to do on your spreadsheet. If you do averages, you can also, another cool thing that you could do is look for a climate analog and try to imagine the future in your community. So this is a school down about 300 miles south of us that is a potential climate analog for what Fairbanks will look like in the future. So the climate there could be what Fairbanks has in the future. And if you look at just the difference by doing these percentages, down in the Mat-Su Valley, they keep their leaves on their tree and green all the way up until October. Whereas in Fairbanks, we've pretty much lost half of our leaves by mid-September and all of them by the end. So maybe Fairbanks will look a little bit more like the Mat-Su Valley in the future. These are questions that you can ask using phenology data. You also have a ton of other resources available to you. There's other Globe protocols that maybe you've collected or other folks have collected. There's satellite data. So the normalized difference vegetation index, or NDVI is a satellite that tracks greenness. But you can also look at, in the United States, they have a fall foliage map, which tries to predict fall color change. And then there's also a number of different satellites at any given time getting imagery. And this little time lapse here of Fairbanks is a good example of why it's so helpful to have globe data on the ground, because in the case of Fairbanks this fall, it was cloudy almost the entire green down season. And so having on the ground data is really awesome and helpful. So there's a lot of resources available to you. There's one I want to point out here is the research question development. How do you go from observing to asking a question to refining it? A globe educator from Shishmaref, Alaska, which is on Alaska's far northwest coast, Robin Ichowak, recorded a video of her working with her class to walk through this whole process from observation, digging around, thinking about what the concerns of the community are and what the interests of the class are, to asking a question, to revising that question into a testable, globe-based research question. So in the video, she's looking at erosion with her class, but you can do that exact same process with your phenology data with your students. And then there's also lots of globe resources, lots of phenology resources, and you may also have something in your community for local and indigenous knowledge resources. At UAF, we have Project Jukebox, which records audio interviews with folks and then makes them publicly available to people. You might have something like that in your community, or it might just be worth going out and talking to people. And with that, thank you very much. Here's our contact info. Feel free to get in touch if you have thoughts, questions about phenology, or if you want to compare your data with Alaska's data. And good luck with your projects. We're excited to see what you and your students come up with for IVSS. Thanks so much.
Tori and Emily, that's awesome. Thank you so much for your presentation. And if there's any questions, please put them into the chat. There will be, each of these presentations will separately be uploaded, so you can watch them as many times as you'd like. And a list of the resources that contained in each will also become available for you too. Our last presentation is on My NASA data.
Hello, my name is Angie Rizzi, and I'm the task lead for My NASA data. We have a data visualization tool called the Earth System Data Explorer that allows you to look at over 60 Earth science data sets. While we do not have globe data, you can use our Earth science data to provide background information for your globe investigations. You can look at historical data to see what is normal, or you can compare different variables. If you use historical globe data that you can download from the Globe Visualization tool, you can also download data from My NASA data and compare it with your globe data. The rest of this video is a tutorial on how to use the My NASA data Earth System Data Explorer visualization tool. Desiree Wilson, the developer of the tool, will walk you through how to use the different features. Remember, this can enhance your globe data, but not replace it.
My name is Desiree Wilson. Today we're going to learn how to get started with the Earth System Data Explorer 2.0, the data visualization tool provided by My NASA Data. On the Earth System Data Explorer 2.0, you will find collections of Earth science data, primarily collected via satellite and from NASA sources. We'll demonstrate the primary features of loading data for a particular time and location, exploring the data with Identify, generating a time plot, analyzing data with Compare To, and exporting information. When you launch the Earth System Data Explorer, you will see a dataset selection panel on the left and a blank map on the right. If we go to the top left-hand corner of our screen, we are first instructed to select a sphere of the Earth system. These are the atmosphere, biosphere, cryosphere, geosphere, and hydrosphere. For this tutorial, we will select the atmosphere. Next, we will select the Earth Science category of the dataset. We will focus on the category of temperature. Next, we will select a dataset, the monthly surface air temperature dataset. Lastly, we will select a date. We will select 2023 and then select January. Immediately upon selecting the dataset month, the data will load onto the map and a legend will appear in the top left-hand panel. The legend contains the date, the units, the color bar, a plain language description of the dataset, and the source of the data. At any time, you may change your map selection by revisiting any of the steps in the data selection process. You can change the location on the map in several different ways. You may pan around by clicking and dragging, and zoom in and out by scrolling. You may also use the plus and minus symbols in the left-hand corner of the map to zoom in and out. Alternatively, you can search for a specific region or location by using the search bar above the map. You'll also notice that a new panel has loaded on the right side of the screen. This panel includes different analysis tools. The time plot analysis tool allows you to create and view a plot of how the data changes over time in one location. To demonstrate this, we'll select the time plot button. Once selected, instructions for how to create a time plot will appear in the right panel. We are first instructed to select a location. This can be done either by selecting a location on the map or entering in the latitude and longitude. If you decide to enter in the latitude and longitude manually, note that the latitude must be entered as a number between -90 and +90, and the longitude must be entered as a number between -180 and +180. Once you have selected a location, you will be prompted to select the start and end date for your time plot. I'm going to select several years worth of data. We'll say from 2019 to 2022. When you have finished your selections, you must click the Generate Plot button to load the plot. This will generate a time plot for the location and dates you selected. As you can see, the map remains at the bottom, and a point has been added to indicate your chosen location for the time plot. You may also enlarge the time plot. To do this, click the small square button in the right-hand corner of your chart. This will open and enlarge the chart in a new window in your browser. In this view, you now have the option to download the data as a SVG or PNG file. Next, we will return to the main window. To close the time plot instructions, we will scroll down and select the Exit Time Plot button. The plot is then removed, and then we can select a different analysis tool. Next, we will show you how you can compare two different data sets on a map with the Compare To feature. After clicking the Compare To button, you will see that a slider and a blank right map has been added, while the air temperature data and legend remains on the left side. The dataset selection instructions are now shown in the right panel and are used to load data on the right map. These instructions are the same as the instructions on the left. I will select the same monthly surface air temperature dataset, but during a summer month instead of a winter month. You will see that a new legend appears on the right, representing the data for the right map. Now we can move the slider back and forth to compare the two different dates. When you are finished using the Compare To tool, we can press the Exit Compare To button at the bottom of the panel. The Compare feature is then removed, and we can select from the different analysis tools again. Next, we will show you how you can view the data value for a location on the map using the Identify tool. After clicking the Identify button, the instructions will appear in the right panel. We are instructed to select a location on the map. After selecting the location, the data value will now appear in the right panel, along with the location's latitude and longitude. When we select a different location, the information will update in the panel. To exit the Identify tool and return to the main menu, select the Exit Identify button.
And this is Angie Rizzi with some updated features. You can download in a couple of ways. To get the map image, you can click the Generate Download Image button and then download the map. Or you can download data as a CSV file for a given location. To do this, click the Data Table button, and you will enter your location as you have done before, and then put your starting and ending dates as you do when you make a time plot. Once you select those dates, click the Generate Data Table button, and it will come up. If you expand the table with the little window at the top right, the table will come up and the Download CSV button will be on the top right.
Thank you very much for joining us. And if you'd like to learn more about MyNASA Data's offerings, please visit mynasadata.larc.nasa.gov or visit our other tutorials at our YouTube channel. Thank you.
Thank you very much. And Ashley's online, and if you have any questions for her on My NASA Data, please put them in the chat. She's populated it with a lot of links. If there's any questions, now would be a good time. With that, I'm going to leave you with the last bit of information, my email address and Alison, her email address, if you'd like to contact her for any more information. If you're interested in part 2 of the webinar, there's a separate URL to register again. And information on the IVSS with the link is right there also. Thank you to all of our presenters. It was an amazing experience for me. It's always nice to see what projects you're all working on. I so appreciate your willingness to contribute to the project. So thank you all for joining us.